In this video, I'm going to investigate the differentiability of the absolute value of x function. F of x is equal to absolute value of x. So let's go ahead and find out what does it mean for a function to be differentiable. We know that f prime of x is equal to limit h approaches 0 f of x plus h minus f of x divided by h. If this limit exists, then we say the function is differentiable. So let's go ahead and see the behavior for absolute value of x for this function. It's going to be limit h approaches 0, absolute value of x plus h minus absolute value of x, all of it divided by h. So there are three scenarios for this function actually, for this limit actually. Scenario number one, or case number one, case one, when x is positive, x is greater than 0. Then case 2 is going to be when x is less than 0, and case 3 is going to be when x is equal to 0. We are kind of dividing the number line into three groups. So positive numbers, negative numbers, and the 0. Let's consider the positive scenario first. So in that case, what happens? If you have a positive x, absolute value of x is going to be equal to just x. For instance, absolute value of 2 is just 2. Now, in that case, the limit becomes limit h approaches 0, x plus h, okay, minus x, all of it divided by h. Now, you kind of have to be slightly careful here. Think of the case where you have absolute value of x plus h. H is something changing, right? So we need to make sure that the value of x plus h is positive, meaning that our h should be adjusted in such a way so that it becomes x plus h becomes positive or greater than 0. Then this should be fine. Now, if we simplify it, that gives me limit h approaches 0, negative x, positive x cancels out, the h over h, which is nothing but limit h approaches 0, 1, because h and h cancel out, and that is just 1. So if x is positive, then the derivative of absolute value of x is just 1. Similarly, let's consider the case 2. Case 2, where x is negative, meaning x is less than 0. If x is less than 0, then absolute value of x is going to be, by the way, negative x. Remember that. Once again, the limit becomes limit h approaches 0. Now, we need to also remember here, since absolute value of x is negative x, our absolute value of x plus h must be adjusted such that, so this is going to be negative x plus h, right? So we need to make sure that x plus h is less than 0, okay? We need to make sure of that. So this x plus h is less than 0 for this to be true. And we can adjust the value of h in such a way so that that condition holds true. So then this becomes negative x plus h minus negative x, okay? All of it divided by h. So this in essence becomes limit h approaches 0, negative x minus h, negative and negative is going to make it positive, x divided by h, and that gives me limit h approaches 0, negative h over h, which is limit h approaches 0, negative 1 over 1, right? Which is just negative 1. So when x is less than 0, f prime of x is actually negative 1, and for x is greater than 1, f prime of x is positive 1. Now let's investigate the case 3 when x equal to 0. Case 3, x is equal to 0. If x equal to 0, what happens? So this limit, okay, becomes the following. We have f of 0 plus h minus f of 0, which, by the way, is something very simple. Limit h approaches 0. This becomes f of h minus f of 0, all of it divided by h. And that ultimately becomes limit h approaches 0. Now f of h is just absolute value of h, correct? Minus f of 0 is absolute value of 0, which is just 0, divided by h. That gives me limit h approaches 0, absolute value of h over h. So this is the limit that we need to investigate. Now, if you are approaching 0, if h approaches 0 from the positive side, okay, from the positive side, then of course absolute value of h is just h, right? So we are gonna find the limit h approaches 0 from the positive side. Then I'm gonna have absolute value of h over h is gonna be is equal to limit h approaches 0 h over h, which is just 1. So that's the right limit. Now for the left limit, what happens? Limit h approaches 0 from the negative side, absolute value of h over h is going to be equal to limit, oh, I forgot to put the positive sign here, limit h approaches 0 from the negative side. Now if h approaches 0 from the negative side, however small the value of h is, it does not matter. H is always going to be negative, right? So absolute value of that is going to be negative h, okay, divided by h, and that limit is, by the way, negative 1. Now look, right limit is positive 1 and the left limit is negative 1. When approached from right, the point 0, you get the derivative to be 1, and if you approach the point 0 from the left, you get the derivative to be negative 1, and these two limits are not equal. That means this limit, right limit and left limit, are not equal, meaning that the derivative does not exist. Now to summarize, for f of x is equal to absolute value of x, it has three scenarios. Scenario 1, if x is greater than 0, f prime of x is equal to 1. Scenario number 2, if x is less than 0, f prime of x is equal to negative 1. And scenario 3, if x is equal to 0, f prime of x does not exist. Now, while I'm on the topic, I kind of want to talk about another thing. Consider a function, just any function, that's defined on, let's say, the interval negative 1 to 1. This is a closed interval. And let's say this is a polynomial function or any function, it doesn't matter. It's only defined, so remember, it's only defined on the closed interval negative 1 to 1. The function is continuous here in this interval and differentiable. However, the function will not be differentiable at the boundary points. Why? Because for the very reason that the right limit will exist, okay? For the left, for x is equal to negative 1, the right limit will exist, right? As you approach negative 1 from the right side. But the left limit does not exist because the function is not defined. Why is it not defined? Because look, this is negative 1, right? The function is defined up to here. okay, up to this point. Anything to the left, the function is not defined. If a function is not defined, the question of differentiability does not even exist. So it's not differentiable. So in the closed case, if you have an interval where the function is continuous and differentiable, but the interval is closed, then the boundaries are where the function is not differentiable. That's another scenario you can think of. Anyhow, I hope that this discussion was helpful. Thank you very much.